Okay, folks, I hope you can see this. We are going to be talking here about the systems of linear equations in general, which is more than what we had in the past. We had the system of 2 by 2, so you have 2 equations and 2 unknown. And now we're going to be talking about a system that are with 3 equations with 3 unknowns. So something like this one here. So this is straight from the lecture that we have in the class, lecture number 9. I hope you can follow that. You have the lecture on the blackboard, so you can open that lecture and follow the lecture by using your paper. It's probably going to be easier to see than what you see on my whiteboard here. I'm going to try to make it a little bit closer just so you can see it better. Okay. But in any case, I have 3 equations. The first equation says x minus y plus z is equal to. The second equation says 2x minus y minus z is equal to -1. And the third equation says x plus 2y minus z is equal 1. Now, as you can see, those are 3 equations, and they have 3 unknowns. Right? This is the first equation, this is the second equation, this is the third equation, and 3 unknowns are x, y, and z. Now, the unknowns don't have to be called x, y, and z. They could be something else, but if you have an x, y, and z, that's a typical thing that we usually have when we're working on the equations. Okay, so what is this story about? Well, since we have that 2 by 2 system, which are 2 equations with 2 unknown, that was like intersection of 2 lines. Now, these are not lines. Moreover, we have a 3 variables, so instead of having an x and y dimension, which was in the plane, Cartesian plane, we have an x dimension and y dimension, which was the x coordinate and y coordinate for any point. Now we have x, y, and z. Well, that means that we are in a 3-dimensional space. So we have the one direction, which would be x direction. We have another direction, which would be the y direction, and then we have a third direction, which would be the z direction. So when you are looking for a point in a 3-dimensional space, you actually have to find that point by using 3 numbers. So you're going to travel from the origin. First, you're going to travel in the x direction, then you're going to travel in the y direction, and then you're going to travel in the z direction. Obviously, the same as before, there is a positive direction and negative direction. So if you're going forward, that's positive. If you're going backwards, it's negative. If you're going to the left, to the right, that's going to be positive. If you're going to the left, it's going to be negative. If you're going up, that's going to be positive. If you're going down, that's going to be negative. So what we are looking for here is to find that point that has x, y, and z, so they could make all 3 equations at the same time true. Now, I can tell you what that point is because I already have solved this system, and it's not really that hard to find it. And this particular system has the solution 1, 1, 2. You can try that. If you plug 1 for an x, if you plug 1 for a y, it's going to be 1 minus 1, that's 0, and z is 2. So it's going to be a statement 2 is equal to. That's, of course, true. If you try the second equation, you have 2 times 1, so 1 for an x, you have 1 for a y, so you give a 2 minus 1, which is 1, and then you have a z, which is 2, but you're subtracting 2, so you have 1 minus 2, which is going to be negative 1. So that is also true. And again, the solution is 1, 1, 2. So if you plug 1 here for an x, 1 for a y, you're going to have a 1 plus 2, which is 3, and then you're going to subtract 2. So 3 minus 2 is equal 1. So this is also true. So I already know what that point is. That is a point 1, 1, 2. That is going to make all of this true. Again, the point is in the space. So I have 3 dimensions. I have an x coordinate, I have a y coordinate, and I have a z coordinate. So what are the equations? That's a good question. Well, the equations are actually equations of the lines, of the planes. So this first equation is an equation of a plane. So like you have a plane in space, like that. Okay. The second equation is also an equation of a plane. So you have like 2 planes. Now, if you're looking for the point that is in the intersection of 2 planes, that's generally going to be a line, right? 2 planes will intersect. They will have a common line, right? That's the line. Right? Now you have a third plane, which is the third one here. So you're really looking at intersection of a line, which is the intersection of two planes, with another plane. So now, how is line going to intersect the plane? Well, in a point, in general. But that's a general case. So you could have something else. For example, you could have three planes intersecting in a line, like this. So one plane, another plane, they intersect in a line. You could also have them all three parallel. They won't have any intersection. Or maybe two are intersecting, but the third one is going to intersect the second one, but not the first one. It's going to be parallel to the first one. So you can have two parallel and third one intersecting both of those parallel planes. So then you're not going to have any point in the intersection. So there are lots of different cases you could have. You could also have three equations. There are all three equations of the same plane. How could that be? For example, x plus y plus z is equal 1, and then double that. 2x plus 2y plus 2z equal 2, double that. 4x plus 4y plus 4z equal 4. This is all the same thing. It's the same plane. The first one is the same as the second one, the same as the third one. The equations are not the same, but the planes are the same. Just like you have with the lines. If you multiply equation with any number, it will not change any point. All of that was true before will stay true. So there are lots of different special cases you could have. But in most general situation, you're going to have one point in the intersection. Again, two planes will intersect in a single line, and that line will intersect the third plane in a point. So you're going to have one point in the intersection. So now the question is, how do you find that? You have these three planes or three equations, and you need to find a point in the intersection. Well, obviously, one of the things we are not going to be doing is graphing. Why? Because I don't have a holograph. So I need to have a holographic projection to show you the plane, and then another plane, and then another plane in 3D, so you can see where they intersect. It will be very difficult to do. Again, I don't even have a holographic projection, so I cannot do that. The only thing I can do is to try to do substitution method or elimination method like we were doing in the 2x2 case. So substitution method is a bit tedious. Okay, what you really have to do is to use one of the variable here in one of the equations. Let's say you use x in the first equation, so you move this y and z on the other side, and then you use that x and replace it in the other two equations, so you get a system 2x2. That's going to be kind of difficult to work with. Okay, lots of possibilities to make an algebra. So we have the third method that we were doing with 2x2, which is the method of elimination. Now, a method of elimination is much better here. Okay, so the method of elimination is going to work nicely. How is the method of elimination going to work? Well, for one thing, it's good to have a label. So I'm going to call the first equation the first equation. I'm going to call the second equation the second equation, and third equation, like this. These are not numbers. They're just label for equation. If you are surprised with numbers, I can use the labels. Equation number 1, equation number 2, equation number 3. Okay, like that. Those are not terms of any kind. I just label for the first equation. I have this label. For the second equation, I have this label. For the third equation, I have this label. So what you really need to do with the method of elimination, you have to use all three equations, and you're going to use them in a way that you are going to create a system of 2x2 that you can solve, that you know how to solve, because you were doing that in the past. Two equations with two unknowns. So you need to eliminate some terms. Now, the terms that you can eliminate here is this one and this one. So if you use the first equation, which has a plus z, and the second equation that has minus z, and if you add them, z will disappear. So that's what I'm going to do. So I'm going to add the first and second equation. And you have to do that term by term. So you have an x here, you have a 2x here. If you add that, you will get 3x. Then you have a negative y here, and you have a negative y here. If you add these two, you get negative 2y's. And then I have positive z and negative z. If I add positive and negative z, I have nothing. I'm not going to write that. You could write 0, but I'm not going to write that. And then you have these two. Here is 2, here is -1. You have to add these 2, and you will get 1. So now you have the first equation that involves, this equation has 2 variables only, okay? But you're not done, because this is not enough. You just have one equation with 2 unknowns. We need to have more. We need to have another equation with 2 unknowns. So what I'm going to do now is I am going to use the third equation. Why? Because I have not used the third equation yet. I cannot lose that. This is an information about the point. I cannot lose the third equation. Third equation is an extra information about the point. So I have to use the third equation now. You can use also the third equation with either second equation or the first equation. So I am going to use it with the first equation. Why? Because I'm seeing here z positive and negative z. Since I eliminated z by using the first and second equation, that's how I get this equation, I have to do again the same. I need to eliminate z again. So I have to do, I'm going to use the third equation and the first equation, I'm going to add them. So I'm going to get the first equation plus the third equation. I'm adding these two equations. And again, I have to be careful. So I'm adding x plus x, which is going to be 2x. I am adding negative y plus 2y, which is going to be positive y. And now the trick. I am adding positive z and negative z, which is, all, of course, going to be 0. So I'm not writing that. And on the other side, I'm adding 2 and 1. And that is going to be 3. Now you can see the major thing I have accomplished here. What I have accomplished here is that I have 2 equations, and they are in the x and y, and z is gone. I don't have z anymore. So because of that, this is a major thing that happened. I now have a system of 2 by 2. And I can solve the system because I know the methods from the past. I can solve the system by using the method of elimination. I can solve it by using graphing. I can use it by I can do that by using a method of substitution. Either of them will work. So I can do either one of them, and those methods should work for me. Okay. But since I, of course, use method of elimination, I want to try method of elimination again, right? Because that's the thing to do. So what am I going to do with method of elimination? I'm going to eliminate y. You can see here I have negative 2y, I have positive y. So if I double this, I'm going to have a matching term. I'm going to have negative 2y and positive 2y, and I'm going to add that, and I'm going to eliminate the y. So now my next step is just simply multiplying second equation with 2. I'm going to keep the first equation. The first equation is 3x minus 2y is equal 1. And the second equation I'm going to multiply with 2. So it's going to be 4x. It's going to be 2y. That's the goal, right? I'm going to match these two terms. And this is negative 2y, and this is positive 2y. And I also, of course, should not forget that the double 3, I'm going to get 6. And now, so this is the preparation for elimination step. And I am going to now add these two equations. I'm going to add 3 and 4x, which is 7x. I'm going to add negative 2 and positive 2y, and that's 0. And on the other side, I have 1 plus 6, which is, of course, 7. Okay? You can see what an x is. X is 1. So 7x is equal 7. That gives me x equal 1. Now, this is only a third of a solution. Okay? You only have an x. You still need a y, and you still need a z. So when you have an x, you have to go backwards. So you have to go backwards in one of those equations here that has an x and y. You know x now, you can find y. I am going to use this equation. This is 2x plus y equal 3, right? But now I know what an x is. So I'm going to use 2x Looks like some of my markers have dried out. Okay, I have 2x, and I'm choosing this equation. Plus y is equal 3. Okay, I am going to replace the x with 1, because I now know that x is equal 1. Remember how do we do that? We use a container, you place the value in the container, and then you work it out. So what it says here is 2 times 1 plus y is equal 3. Obviously, y is 1. Right? So you have immediately y equal 1. Right? 2 plus y is equal 3. What could y possibly be? 2 plus something is equal 3. That something must be 1. So now you have a y. Okay? So now you have a 2/3 of the solutions. 2 out of 3. You still need a z. Okay? Now you can go back to any of the previous equations that contain z. Well, where do you have them? Well, on the top, right here. This 3. You can use the first equation here. So now going a back substitution, what this equation is, let me write it down. It says x minus y plus z is equal 2. Okay? Well, I know x. X is equal 1. So I'm replacing x with 1. I also know y. Y is equal 1. Okay? And I don't know z, but now I'm going to find it because now I have a full information about z. It says 1 minus 1, which is 0, plus z is equal 2. So basically what it says, z is equal 2. Okay? So now I have the whole solution. I know x, I know y, I know z. So the solution of this system is 1, 1, 2. That's one way of writing it. You can also write x is equal 1, y is equal 1, and z is equal 2, which is okay. So you can. So this is the way you would write solution, but you could write like a point in the 3D space. So it has x, y, and z. Or you could just simply write x is equal 1, y is equal 1, and z is equal 2. Right? Needless to say, when you're in a test situation, you should actually check. You should check your solution. So which means those 3 values, 1, 1, 2, you should plug in the original system and make sure that it turns out to be true. Every equation, the first one, the second one, the third one. Now, if that is not so, that means you made some algebra mistake on the way, and that's very easy to do. And you will know that you didn't really find a solution. You found something that it looks like a solution, but it isn't really a solution of the system that you are looking for. Again, it's very easy to make an algebra mistake. You see, I've made lots of algebra steps here. So if I'm not careful about it, I can easily make a mistake, right? So this is one very simple example. Let me do the example number 2, which is also in the lecture. Again, I am using the lecture number 9, which is on the blackboard. So that lecture you can open yourselves. You can say to me, well, I don't see this very well. You are talking too fast and so on. Open that lecture. Look at that. Okay, I'm not changing anything about it. Let me just erase this. So I am now going to use the second example in the lecture to go over that one more time. So you can see that. So the second example is also a system of 3 by 3, and it goes like 2x plus y plus z is equal 2, and then I have 2 more equations. So these are planes, minus 2y plus z is equal 0. And the third equation is says x minus y plus 2z is equal 4. Okay? Again, the numbers I'm giving you here are very simple. 1, 2, 3, 4. How hard is it, right? Again, the numbers don't have to be nice. You could easily have fractions, you can have decimal numbers, who knows, right? But I'm using something really simple. Okay, so this is the first equation, this is the second equation, this is the third equation. So each one of them is an equation of a plane in three-dimensional space, and you are looking for the point that belongs to all three planes. So you're looking for an x and y and z that will make through all three equations. It has to make first equation true, and you plug x, y, and z. It has to make second equation true. It has to make third equation true, and then you have a solution. Okay. Again, I could do it by hologram. So I have to find one plane, I have to find another plane, I have the third plane to see where's that point. That is in O3. But that again is excluded because I don't have a holographic projection. You can see I have a lousy small whiteboard. Even if I have it, it will be very difficult to see. I can also use a method of substitution, but we're not going to do that. I'm going to go immediately on the method of elimination. Okay? So what's my method of elimination here? I think it's obvious. For a moment, at least one step. Okay? I see y and negative y here. So y and negative y. What is that telling me? I'm going to use that. Because if I add those two, that's 0. So I'm eliminating y. Okay? So again, plus y, negative y. First equation, third equation. If I just add them, y is gone. So that's my plan. So this is equation number 1. You can write equation number 1, equation number 2, equation number 3. You don't have to, but it's a kind of good idea to have some kind of label so you know what you're doing. So then you write, I'm going to add equation number 1 and equation number 3. Okay? So the plan is to add this equation and this equation. This is an equation. This is an equation. I'm going to add that term by term. Everything. The only thing you're not adding is a sign of equality, right? You can't get 2, right? So you have 2x plus x is 3x. As I said, y and negative y is 0. Obviously, that's the whole idea, okay? And then I have a z and 2z, which is 3z, okay? That's the left side. I just added the left side of the first equation and the left side of the second equation. Now I have the right side. I have 2 here and I have 4 here. Again, you're adding the first and the third equation. And that would be 6, right? Now see what is accomplished here. I have an equation with x and z. And I don't have a y. So now I need another equation the same way with x and z and without y. So which means that my elimination step, you're going to have to remember that the strategic move has to be to get rid of y. So I'm doing now, and now I have to use the second equation. Why? I didn't use it yet. You cannot drop the equation, right? You cannot say, oh, I don't need this equation, let's just drop it out and let's work on the other two. No, you cannot do that. Because then you're going to lose information. Then you're going to get the intersection of two planes, but the third plane is completely gone, right? You cannot do that. So you must use the second equation. And so now I have to use the second equation, and I have to get rid of y. Now, what I need to do here, and you can clearly see here, I have y here, and I have negative 2y. So what is that telling me? If I want to use this y and this negative 2y, I would need to have either a single y negative in the second equation or a double y in the first equation. So which means I will have to divide the second equation with 2 or multiply the first equation with 2. The multiplying the first equation with 2 is the good idea. Dividing, it's not particularly a good idea because you might end up with fractions and you don't want to work with fractions. You could, but it's not something anybody's all that skillful, right? So you work with fraction, you have a great chance of making mistakes. So I'm going to multiply the first equation with 2. So what I'm doing here, I'm multiplying the first equation with 2, and then I'm adding the second equation. So that's the plan. So that's like a blueprint, what I'm doing. So I'm multiplying the first equation with 2, term by term. Look at that. I have 2x, double that, so this multiplying with 2, you got 4x. And you add another x here, that's 5x. I hope you follow this step because it's very important. You multiply this one with 2, and you add negative 2y, so you have a 2y plus negative 2y, that's 0. And then you have this one, time 2, that's 2z, plus this z, that's 3z. And the same thing on the right side. 2 times this, which is 4, plus this, which is 2. Okay? So again, if you're not sure what you're doing, write double the first equation first, and then add. But it's really not that hard. 2 times this, plus this, that's 5x. 2 times this, plus this, 0. 2 times this, plus this, 3z. 2 times this, plus this, 4. Oh, okay. I discovered my mistake. You probably noticed that, right? I forgot to multiply the first equation with 2. But this is my new system, okay? This is very important. Why? I don't have any y here. So I have only 2 variables. And I know how to solve this because in the past we were doing this by using the graphing, substitution method, elimination method. Of course, I'm going to use the elimination method because the beauty is that I'm going to continue to use the same thing I was using before. So I'm going to have, again, what am I going to do here? I'm going to eliminate z, obviously, right? Look at this. I have 3z, 3z. I can just subtract, right? The overall routine would be, if you really don't want to go immediately into subtraction, multiply the second equation with -1 until you get -3z, and then you add with 3z, and that's 0. But I don't need to do that. That's just going to subtract. So this minus this, -2x. This minus this, simple. This minus this, 2. Okay? So I have to multiply -2 with something, x, to get 2. That must be -1, obviously, right? Now you can say, I'm going to divide with -2, so I'm going to discover x is equal to -1. One way or the other, dx is equal to -1. Okay? So that is very important, right? So I have first third of my solution. I still need the y, and I still need the z. But I have x, okay? So how are you going to find the y or z? Well, we go backwards, all right? Now, you can't find the y first because you need, for a y, you have it only here. So you need to know both x and z to find the y. But you can find z, okay? You can use any one of these 2 equations. Look at this one, okay? But you can just plug in x and get a z. So I'm going to do that. So I'm going to use this equation, it says 3x. I'm going to write this a little closer, plus 3z says it's equal to 6. Okay? Now we know what an x is, right? I just found that to be -1. So I'm going to replace the label with -1. So I have now 3 times -1, which is -3, plus 3z is equal to 6, which basically, this is -3. So on the other side, it will become +3. So it's going to be 6 plus 3, which is 9. So you're going to have 3z equal 9, right? And it's obvious what the z is. Z is 3. Okay? So you have z equal 3. So you have a second value, which means you have now 2/3 of your solution. Again, solution is triple number. X, Y, Z. All right? So you have an X, you have a Z, you need a Y. Okay, that's not hard because now I can use any one of the first 3 equations when I have a Y. You know what? I'm going to use the first equation. The first equation says 2x plus Y plus Z is equal to 2. Okay? I know what an X is. -1 I know what the z is, so I'm using this typical method wise used in the class. I'm going to use a container. I'm going to place the value of the variable in the container. Okay. So what is this? I have -2 plus y plus 3 equal 2. You don't have to be Einstein to find z here, but hey, you have a 3 minus 2, which is 1. 1 on the other side becomes -1, so you have 2 minus 1, which is 1, and one way or the other, y is equal 1. You're done. So you have now x, y, and z. Now, I am not going to be checking this, but you will. All right? So I'm going to tell you, well, I'm quite sure that I have a solution here. But you, in a test situation, you cannot say that. Because if you made any mistake on the way, anywhere, a little algebra mistake, some wrong sign, wrong subtraction, or you forgot to multiply with 2, like I did already here, right? When I was multiplying something with 2, then you're going to have a problem. Because you're going to find a point that is really not going to make this true. Maybe one of them true, maybe two of them true, but the third one not. And then you have a problem. So again, in the test situation, you have an x, you have a y, you have a z. You need to plug that in the first equation, in the second equation, in the third equation, and make sure each one of them holds true. Okay? You do have a solution. You can write it this way, but it's kind of when we're doing algebra, we write as a point. So you have a -1, that's your x. You have a 1, that's your y, and you have a 3, that is your z. So this is the short way, smart way of writing the solution. So you don't have to write everything down. You could write x is equal -1, y is equal 1, comma, z is equal 3, and you know what it is. Okay? All right. So that's the second example. Let's go on in the lecture. I'm going to do the third example. Now, the third example, I had just a little trick in the third example, a little thing over there, because I want to show you that you could have a situation when you have to deal with fractions. I mean, your prof is not necessarily always going to give you 1, 2, 3 numbers. You might end up with working on something that is a little bit harder to work with. Okay? And obviously, when I'm teaching you in the class, I always try to cook my example. I want to make it really easy for you so you don't choke on any kind of bone there. But in the homework, you can probably see that there's lots of bigger numbers of fraction, things like that, which means that the algebra work has to be very careful. Right? So I have this third example, which is in the lecture. Again, the lecture is number 9. It's on the blackboard. Okay. I said I told it in the class. This is a lecture that is the thing that you're going to have for the test number 3. It's not going to be in the test number 2, but it's going to be in the test number 3. So you better study this stuff. Okay. So the first equation is x minus 2y plus 1/2 of a z, and says that is equal to 2. Okay. I hope I wrote this nicely. I'm gonna make this z look slightly better. All right. I make a z with a bar in the middle so you can make a distinction. This is not 2. Okay. And then the second equation, I have 2x minus y plus z, all right, equal 1. This is what we do in Europe. We write those bars, so just nobody gets confused. Is it z or is it 2? And the third equation is x plus y plus z is equal 1. Okay, so you have one little problem here, 1/2 here. It's not much of a fraction. It's not really that complicated. It's 1/2 only. But it's a problem because if you're going to be working with this, you're going to have to work with fractions. So what we said in the class, so this is the first equation, this is the second equation, this is the third equation, so you can label it. Equation number 1, equation number 2, equation number 3. Okay? I'm just labeling it. So this is not a part of the equation, it's just a label. Like we label lines, right? Line L1, line L2, or line L, line K, and so on. Right? So I could say plane 1, plane 2, plane 3, but I'm not gonna do that. I'm just gonna call them equations. Okay, so I have the first equation, I have the second equation, I have a third equation. So what I want to do here is first get rid of fractions. And you have to remember what we were doing in the class. We said in the class that to get rid of the fraction, all you have to do is to multiply with the common denominator. That's the story. So if we have two denominators in the first equation, find the common denominator, multiply across the board with the common denominator, and all the fractions will be gone. What has changed? Nothing. I mean, you change the first equation, but it's still the same plane. Because whatever was true before is true now. So we said that they're equivalent. If you multiply equation with a number that is not 0, the next thing you get is an equation that is going to be equivalent to the equation you had before. So that's how you have to do it. If the third equation has 3 fractions, common denominator again. You have 3 denominator, 3 fractions. You could have 4, like 1 here, 1 here, 1 here, 1 here, right? Common denominator, multiply the equation with the common denominator. And if you do that right, all the fractions will be gone. So that's what I'm doing here. I have only one denominator in the first equation. There's 2 here. There are 1/2 here, right? I'm multiplying the first equation with 2. So that's my trick. I don't even have to write anything especially new. I could just do it here in the first equation. I'm going to write it all over. Okay, 2x minus 4y plus z equal 4, right? So again, I am multiplying the first equation with 2. You must be aware of that, right? You have to multiply every term. Any term you forget, you will change the equation. It will not be equivalent to what was before. You had a different equation, and you're going to have a different solution which will not work in your system that you started with, okay? Unless by coincidence. But that coincidence is, chance of coincidences here are very low. Okay? Now the second equation and the third equation are going to stay. I'm just going to copy them. See? Again, I could have done this on the scrap paper and just copy from the scrap paper what I have for the first equation, but now I have to write everything down. Okay. Again, strategic goal is to eliminate one variable. The one that is the easiest to eliminate. Now you can choose which one you want, but the idea would be to use the one that is the easiest to eliminate. So I could use here z, right? This minus this, zippo. This minus this, zippo. I'm done. In the paper that I have for you in the lecture, I actually eliminated x. So I want you to read that. It's going to be a little bit different than what I'm doing here, all right? Another thing also you could do, you could replace the equations. So you could put this equation which looks the best to the first place, right? That's really not that hard to do. You can easily do that. And we'll have to squeeze it, though, right? So I'm squeezing, I have x plus y plus z equal 1, right? What I have done here, instead of having the third equation on the third place, I put it on the first place. Why? Because it looks the best. X plus y plus z is equal 1. You really don't have to do that, but you are perfectly okay if you do that. What are you saying here? Well, instead of having 1, 2, 3 equations, I could have 3, 2, 1 equation. I could have 2, 1, 3 equations. So it makes no difference, right? The equations are equations. They could be reordered. It's not necessarily to have the first equation always the first equation. If you think this is something better to use, by switching the equation, you can do that, okay? So again, let me write this nicely again. So what I have here is I decided to have this third equation that is just x plus y plus z is equal 1, to have it on the first place, because it looks like good equation to started. And then I said I have the first equation here, the original first equation. I double that, so I have 2x minus 4y plus z equal 4. And the second equation, I'll just copy. And now the second equation has become third equation. All right? So let me review this one more time, because I might have confused you, but I don't want to confuse you. So what I have done, I have this third equation, I put it on first place. Then I have the first equation here, I double it and put it on second place. And then I have the second equation here, I just have to put it on the third place. Right? I have not changed the solution. Solution is still the same. Because I multiply one equation with 2, that did not change the truth of that equation, because we know that from before. If you multiply equation in non-zero number, the truth of that equation will not change. And I just reordered them. I put that third equation in the first place and the other two after. So that is also not going to change the truth of the system. I mean, whatever is true for the first equation is true whether it's on the third place or on the first place. Makes no difference. Okay, or it could be in the middle. Right? Now I'm going to do the work. I'm actually going to kill z. The reason why I'm killing z is because I have a very easy work to do here. Again, in the lecture, I have killed x. So I multiply this one with -2, and then I have here, that will be the first equation, and then I multiply this one with -2, and I have here, I have the second equation. So that's done in the paper. I want you to read that. Right? I'm going to now kill z, because I think it's easy. Look at that. Z minus z, z minus z. So what I'm going to do here is the first equation minus the second equation. Okay, this refers to the previous step here, not this one here, right? Because original equation, I already reordered them. I put them in a different order, right? So this refers to this one here. So this is the first, this is second, this is third. So I'm having this minus this, negative x, y minus 4y. Very careful here, you can make a mistake in sign. So y minus 4y, that's 5y's. Okay? Z minus z, zippo. On the other side, 1 minus 4, minus 3. So this is my subtraction. Again, what I have done here, I have subtracted first equation minus second equation. You have to be keenly aware of that. Okay? You have not used the third one. You must use the third one now. But I'm going to do the same thing again. I'm going to subtract E1 minus E3. Now I'm using the third equation. Okay? So you have to use the third equation. You can use the first equation and the second equation, but you have to use the third equation. So why am I doing that? Because this minus this is also 0. I mean, z minus z. The first equation, the third equation. All right? So that's what I'm doing. The first equation minus the third equation. So I have x minus 2, x minus 2x minus x again. This is great. And this one plus this one. Oh, excuse me, minus. Yeah, that's a minus. I'm already losing the trade. This plus this minus this one, that's 2y. Again, why? Because I'm having this one minus this one. So minus y is plus y. So y plus y, that's 2y. And I have this z minus z, that's 0. And I have 1 minus 1, which is also 0. Perfect. It looks fantastic. Okay? Look what I have now. I have a system in which I don't have any more z. I don't have an x and y. Now this is like a story we had in the previous lecture. You know how to do this. You can do the lines, you can do the substitution, you can do the elimination. I'm going to do the elimination because this is easy stuff here. See, negative x, negative x. So I'm just going to multiply the first equation with -1 to get positive x. If I multiply that with -1, I'm going to have an x minus 5y equal 3. And the second equation is still the same. Negative x plus 2y is equal 0. Right? Now, you don't have to be an Einstein to find out when you add these two, you're going to have no x, x minus x, 5 negative plus 2y, that's -3y, And on the other side, you're also adding 3 and 0, which is equal 3. Look, how easy is that? I have y equal -1. That's my y, okay? And you can go back now to any of the equations you had before. The equation that is really easy to use is this one here. It says, this is back substitution, it's another step. So I have -x plus 2y is equal 0. And I know what a y is, so I'm going to replace the y with the -1. And you have now -x, -2 is equal 0. Or put x on the other side, x is equal -2. Okay? So now x is -2. And the last thing you need is z. You have x, you have y. Look at this equation that I have here. X plus y plus z, really nice equation. So I have that back substitution. So I have an x plus y plus z equal 1. So you're going to replace x with -2. I'm using container. I don't have to, but I'm using it because it's a good habit to have it, right? Like I put a seat belt, even if you don't need it. Y is -1. And I have z. And that is equal to, the equation says 1 here, right? This one here. What do I have here? I have -3 here, right? -3 plus z is equal 1. Well, what do you need to add to -3 to get 1? 4, I guess, right? So put 3 on the other side, you get -3, you get 3 here, 1 plus 3 is 4. So you have z is equal 4. Done. Okay? So what we have here is complete solution now. The solution is, what is the solution? Okay, the x is -2, y is -1, and z is 4. I hope I didn't make a mistake anywhere. Right? Yeah, -2, -1, and 4. Okay? So, what I want to say to you here, this is an example when you have a fraction. Again, if you have a fraction in any equation, you look at that equation where you have fractions, count how many fractions you have, find all of the denominators, find the common denominator, and that equation you're going to modify by multiplying the whole equation with the common denominator. That should simply get rid of all of the fractions. But you have to be careful, okay? What you should not expect, so this is the end of the story here, you should not expect to have always integer solutions. So it doesn't have to be 1, 1, 2, 2, 3, 1, 1 point, 1, 0, -1, stuff like that. People easily have a solution that is like 1/2, 2.7, and 3.9. Why not? So again, the solution is not given to be an integer, the whole number I'm talking about, right? Integer are the sign whole numbers, right? You got to remember that. So it doesn't have to be a whole number. It could easily be a fraction. It could be a decimal number. Okay, so you should get used to that, and you will see that in the homework. Also, the variable don't have to be x, y, and z. All my 3 examples that I was talking here are the x, y, and z. But that is not necessarily always the case. If you're doing physics, it might easily be s, t, and v. Why? Because they're going to use, I don't know, something like s stands for the distance, usually t for time, v for velocity, or something else. U, v, w. Why not? Okay, it depends. What is that about? And the difference is just a cosmetic difference, because when the variables are with different labels, it's still the same story. Again, we have to use all 3 equations to kill one of the variables, eliminate one of the variables by producing a new system of 2 by 2. All right? So that's how you do it. Don't expect to always have a one solution. It could easily happen that you have no solutions, or that you have many solutions. Okay? Now, how is going to happen? How are you going to recognize that? Okay, I'm just going to give you a brief example. All right. You could have no solution if the planes are parallel, just like lines. They will never intersect. Or maybe two planes are parallel, they will never intersect. And third plane might intersect the first two, but because you don't have all three intersecting, you don't have anything that can make all three true at the same time. Okay? So something like this. Here is an example. X plus y plus z is equal 1. X plus y plus z is equal 3. And let's say x plus 2y minus z is equal 7. There you go. This system has no solution. Why? The first two are parallel. Okay, you don't know that because you don't know much about planes, but you can clearly see that first one says x plus y plus z is equal 1, and the second one says x plus y plus z is equal 3. That cannot be. It can be either 1 or 3. You can't have both. Okay, so this is perfectly good equation. This is perfectly good equation, but these two equations do not have anything in common. Whenever you have an x and y and z that is equal 1, you can have that when you add that to be equal 3. Okay, so this system will have no solution. So at some point, you're going to run into something like 3 equal 5 or 0 equal 1. That should tell you that you cannot continue. Because if you in your work end up with, just like we have a 2 by 2 system, when you end up 0 is equal 1, you know that's not true. And you started working those equations, so you expected this to be true. Because it's not true, that means the original system has no solution. On the other hand, you could also have a situation like this. So what you see here, the second equation is just to double the first equation. And double the first equation, that's the second equation. And now the third equation might be something else, like something like this. There's nothing to do with the first equation, the second equation, but you know that first two equations are basically the same plane. This is the same story. Whatever makes the first one true will make the second one true, because the second one is just to double the first one. Whatever makes the second one true will make the first one true. So you basically have two planes. Okay, so you have two planes that will. What I'm talking about. The first plane is given by the first two equations, and is the same plane, and the third equation gives you another plane. So when you intersect two planes, you're going to have a whole line. There's not many solutions. There are many points on that line. Right? You could also have actually even worse situation. I mean, worse, more peculiar situation. You might have like, 5x plus 5y plus 5z is equal 5. That is actually the first equation multiplied with 5, right? That will mean that all three equations are the equation of the same plane, which means every point in that plane will be a solution. Every point will make them all three true. Okay? How are you going to recognize it on the way? Well, on the way, you're going to run into something 5 equal 5. If you get that, you know that whatever you were looking for, maybe you were looking for an x. When you get 5 equal 5, that means that the x could be anything. That doesn't mean that y and z will be anything. Right? It might be determined by x, because if you choose an x to be something, you can find that y and z has to be something particularly connected to that x, right? But I'm not going to bother you with it, right? Okay. So I'm not going to bother with special solutions, because we have to discuss really geometry here, and geometry about planes we don't really know, and it's not a part of a topic for our course. Okay. So I hope you understand now this lecture. Again, this is lecture that is based on the lecture number 9 that is on the blackboard, which is written lecture. So you can go through that, you can print this out, and if you didn't follow me exactly, you can watch this video over and over, or you can watch this video by also checking that printed lecture. Okay? I hope I'm done with this. So this is the lecture number 9. It will be on the test number 3. It will not be on it is not a topic of the test number 2. Okay? But it is a topic that will be the very first question on the test number 3. So you need to study it. Okay? I'll see you the next time when we go over the lecture number 10, which we will go once we are done with the test number 2. Okay? Take care.